Geometry, Chapter 4, Section 2. Triangle congruence by SSS and SAS. The objective is to prove two triangles are congruent by using SSS, or side, 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 and SAS, side, angle, side postulates. Okay? Are the triangles congruent, and how do you know? Well, we'll have to measure their sides. Okay, right now, the way we've done it is we've had to find three congruent sides and three congruent angles. Okay, but there's a much, much, much quicker way to do it. So let's just jump into it. And solve it, we looked at the relationships between corresponding sides and angles. In lesson 4.1, we learned that if two triangles have three pairs of congruent corresponding angles and three pairs of congruent corresponding sides, then they are congruent. All right? Here's the question. Is there a way to prove triangle congruency with less information? Absolutely. Okay? You can prove that two triangles are congruent without having to show all three angles and all three sides congruent. In this lesson, we will prove triangle congruency by using three pairs of sides and two pairs of sides and one angle. Okay? So postulate 4.1, side, side, side postulate. The postulate reads this. If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. So basically, if we can prove AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF, then we can prove triangles ABC is congruent to triangle DEF. Okay? In chapter 1, we learned a postulate that accepts the statement of fact. The side, side, side postulate is perhaps the most logical fact about triangles. It agrees with the notions that triangles are rigid figures. This means their shape does not change until pressure on the side forces them to break. The rigidity property is important to architects and engineers when they build such things as bicycle frames and steel bridges. So knowing side, side, side is true, can we prove triangle LMN is congruent to triangle NPL? Well, we know LM is congruent to NP, so LM is congruent to NP, and we know LP is congruent to MN. So can we prove these triangles congruent? Well, let's look. What do we know is true about line LN? We know LN is congruent to itself by reflexive property. So if we look, we can say PN is congruent to ML, and LN is congruent to NL. So we can say triangle PNL is congruent to MLN. So yes, we can prove congruency. Okay? So let's look at another example. You can also show relationships between a pair of corresponding sides and the included angle. Okay? The word included refers to the angle and the sides of the triangles as shown to the right. Okay? Angle A is included between segment BA and AC. Okay, how can we know that? Well, the letter A is included in both of those segments, so we know angle A, or point A, must be included. So angle A is included. Okay, BC is between angles B and C. Postulate 2 states this. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So if AB is congruent with DE and AC is congruent with DF and angle A is congruent with angle D, the triangles will be congruent as well. So we have side, 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 and now side, angle, side. So look at this problem. What other information do you need to prove triangle DEF, let's highlight it, DEF is congruent to FGD? So let's look. Okay, what do we know? The diagram shows EF and GD are congruent. Okay, it shows it by those little marks there. We also know DF is congruent to itself. So to prove DEF and FGD are congruent by side angle side, we need to prove angle D or GDF is congruent to angle EFG. So we need to prove angle EFD is congruent to angle GDF. All right, so we need to know those two angles are congruent. All right, so question 2. What other information do you need to prove that triangle LEB is congruent? So triangle LEB is congruent with B and L. Okay, how can we prove those two congruent? Well, given we have angle ELB is congruent to angle NBL. We also know LB, segment LB, is congruent to itself. So what do we need? What other information do we need? We need a side. We have an angle and we have a side. So we need to be able to prove LE is congruent to, again, we have a side, we have an angle, BN. So we need to be able to prove this side is congruent to that side. So we need to be able to prove LE is congruent to BN. Okay? Again, we're trying to prove by side angle side. So, problem 3, identifying congruent triangles. Okay. Would you use side, 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 or side angle side to prove congruency? If there's not enough information to prove congruency by side, 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 or side angle side, not enough information. All right, so here I got a side, an angle, a side, and a side. Yes, side angle side, because two pairs of corresponding sides in the included angle are congruent. Okay, here I have a side, I have an angle, I have a side, but look, this is not side angle side. So we do not have enough information. We don't have enough information. See, in the first diagram, the angle is included. In the second diagram, the angle is not in between the two congruent sides. C. All right, so I have a 1, 2, and 3, and I have a 1, 2, and 3. So that's an easy one. So yes, we can prove congruency with side, side, side. D. All right, so I have 1, 2, 3, 1, 2, 3. All right, I also know vertical angles are congruent, so I can use side, 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 or side angle side. Okay. Example 3, would you use side, 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 or side angle side to prove congruency? Well, the included angle is between the third and the second side on this one. The included angle is between the second and first one, so we can't use the side angle side. But we have 1 to 1, 2 to 2, and 3 to 3. So we can easily use side, 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 and only side, side, side. Okay? Lesson check. In triangle PEN, name the angle that is included between the two sides. Okay? Let's see. Between segment PE and EN, what letter is listed twice? E. So we know angle E. In P and PE, which letter is included twice? P. So we know it's angle P. Alright? In the triangle hat, between which sides is the given angle included? Well, let's draw it. Triangle H. Okay. HAT. So what are the two sides between H? Well, segment HA and segment HT. Okay, what about angle T? What are the included sides? Segment TA and segment TH. Okay, number 3. Name a postulate you'd use to prove the triangle's congruent. Well, I have a side and a side. I have a side and a side. Oh, and look, vertical angles are congruent. So I can use side angle side for number 3. Okay, number 4, I have two sides that were given, and we know this side, since it's used in both, by reflexive property, it's congruent to itself. So number 4, we can use side, side, side. Your friend thinks that the triangles below show congruent by side angle side. Is your friend correct? No, my friend is not correct because I have a side and a side. So the included angle would be this one. I have a side and a side, so the included angle would be here. So it's not side angle side. So we cannot prove congruency. All right. A carpenter trims a triangle peak of a house with 3 7-feet pieces of molding. The carpenter used 21 feet of molding to trim a second triangular peak. Are the two triangles formed congruent? We don't know because we don't know the lengths. Not enough information. Okay? Make sure you go through this. Make sure you go through your word problems. And if you can't see the triangles, visualize them. Write them out. Draw them out. Do whatever you need to do to be able to visualize side, 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 and side, angle, side. All right? Again, review it, and we'll catch up with you on the next lesson.